All right, so in this video, we are going to focus on graphing linear equations. And of course, the word line is in the word linear. So this tells us all of these equations, when we graph them, should be lines. Most of them will be diagonal, but we might see some that are perfectly vertical and some that are perfectly horizontal. This is probably the most important section of this unit because the skill we learn in this section you can utilize in later sections. So here are the steps that we're going to use to graph these two examples together. So let's jump right into it and kind of follow along with the steps. So step one says select convenient values to substitute for either variable. So I'm going to make an XY table. And when they say convenient values, they mean small numbers, easy numbers to work with. So the easiest number I know to work with is 0. So I'm going to substitute a 0 for x, and typically that's what we're going to be substituting in for. Most of the time x, but we'll do a little bit of both. So we're going to replace x with 0 in the original linear equation, and just do the quick math to get the corresponding y coordinate. -2 times 0 plus 5 is 5. So that is the first point. Typically, you only need 2 points to graph a line, but for these first couple examples, we're going to graph 5, just so we can see a lot of different combinations. Let's pick one more fairly easy x value. So it's positive 1. It's usually the first two numbers that I always pick. And again, pretty simple math. -2 times 1 is -2, plus 5 is 3. And again, we got all those numbers from the original equation. So the point 1, 3 goes here. And then let's just pick one more x value, and let's pick a negative number. So this time we're going to substitute -1 for x. -1 times -2 is positive 2, plus 5 is 7. So that's going to be a left 1 and up 7. And as you can see, those points are in a perfectly straight line. But I also want to show you, you can pick numbers for y. So let's do the same thing. Let's pick small numbers, but this time let's substitute them in for the y variable. There'll be times where you'll want to do this. So substitute 0 for the y variable this time, and we're going to solve for x. Some cases it's easier. In this case, it's a little bit tougher because we've got a two-step equation. We've got to subtract 5 from both sides and then divide both sides by -2. And we're going to write that as a decimal, positive 2.5. So that is right 2.5 and up 0 units. And we need one more point, so let's pick a convenient value one more time for y. And I encourage you to try this last one on your own. Pause the video if you need to. This time we're going to substitute 1 for y and solve for the corresponding x coordinate. So we want you to see it does not matter which variable you substitute convenient values in for. May make it a little bit easier in some cases. But as you can see, there's your points. We can now graph our line. I don't think I have an official line tool. This will work. And there's our line. It is important to put arrows on both ends because we know we could keep extending this table of values. We stopped at 5 points, but we could easily do 500 points. It would just take a lot more time, obviously. So let's do one more example together, and then you're going to do the to your turns on your own. So this one's a little bit of a different form, but ultimately we can solve this the exact same way. You can decide to put your convenient values in for x. Again, I always like to start with small numbers, -1, 0, and +1. Then while we're at it, I'm going to substitute some values for y. It is important to know you do not have to substitute values in for both variables. I just want to show you a lot of different ways to do this problem. But notice we've picked easy, manageable numbers to substitute into this problem. So first we substituted -1 for x. This one's a little bit tougher because neither one of the variables is isolated to begin with in this problem. When that happens, unless you're really careful about the numbers you pick in your t-chart, you're probably going to end up with decimals. So I'm going to add 3 to both sides, but it is okay to get decimals. They're just slightly harder to graph. So when x is -1, y is -7.5. So that would be our first point right down there. When we substitute 0, you'll see the power of picking 0 is a good one to pick because that's what we'll do next. We're going to substitute 0 for x. And that takes care of the 3 times 0. 3 times 0 is just 0, so all we have to do is divide both sides by 2 and get a y coordinate of 6. So there's the work when I substitute 1 for x. And you always want to double check your points. So I see something is off because I've graphed those 3 points and they do not form a line. So that tells me at least one of these ordered pairs is incorrect. And when I look back over my work, my error is a slight one. That wasn't a positive 2y. It's a minus 2y. So I should be dividing both sides by -2, which would give me the point 0, -6. And now when we graph the point 0, -6, we get a nice diagonal line there. Let's go ahead and just graph one more point because I'm just about out of space to do my work here. And really you only need 2 or 3 points. And let's pick the easy number. Let's substitute 0 for y. So when y equals 0, zero is always a good number to pick for x and y because stuff is going to cancel immediately, and we get x equals 4. So that's our x-intercept, and there is our line. I'm going to try to do this without my fancy tool. And there's your line. All right, so I encourage you to pause the video here in about 10 seconds. I'm going to show you the answer to the first one. So there's my work for that first problem. And again, notice I picked 0 for x and I picked 0 for y, just to make my life a little bit easier. You did not have to pick those same ordered pairs, but your line should look exactly the same. All right, pause the video one more time. This last one looks tricky, but ultimately you're solving it the exact same way we've done all these other ones. Graph at least 3 points, and I'll show you the answer here in just a few seconds. So here's this one. You can see the work. This time I could only substitute 0 for x because the output gave me a 0 for y. So this one goes through the origin. The other two I did get decimals, but they still fell in line with each other. There's the work for when I substituted 1 for x and substituted 1 for y.